the LeetCode problem verifying an alien dictionary. So this problem has been categorized as Facebook's most common interview question of 2020. So in this problem, you are given an input array of strings and another string which specifies the order for all of the alphabets in the string. And you're supposed to return whether or not the input array is in the sorted order. So as an example, I think they have these two words here, hello and LeetCode, and they specified the order. So you can see H is the first followed by L. So because of that, we can say that it's already in a sorted order. Similarly, here second, we have the two words word and world. So here, if you see the order which is specified, L is there before D. So because of that, the second word should be sorted in front of word. So we return false. And here's another example where both the words, they start with the same three characters, but since the second word ends after that and the first word has L and E, we need to sort it where app is in front of apple. So yeah, essentially the way we'll solve this problem is we'll create a comparator, and what we'll do is given the input string, we'll sort the string based on that comparator and then return if the sorted value is the same as the input array. So yeah, let's get started. So first thing I'll do is create a hash map, and I'm using that hash map to keep track of the order which they are specified as input. So now we're going to just add all of the alphabets in the order. So for int So what you've done here is essentially you're taking the order of all of the values specified in the input and you're putting it in a hash map. Next, what you're going to do is we're going to copy the input array. So string so this essentially clones the array. Next thing we do is sort the array copy. So this class we're going to create right now, but for now I think we'll just complete it. So now we have sorted the array. We just return arrays.equals. So now let's implement the class alien comparator. So essentially, if we implement the interface comparator, we could specify our own rules which we need in order to compare. So here we are going to look at what the logic was. First thing we have to do is we have an hash map which stores the order for each alphabet. The next thing we need to look at is that which word is smaller. So for doing that, we are going to create two indexes and use that to traverse down both the strings. So int I is equal to 0 and j is equal to 0. J is smaller than str2. So here we're just traversing it as long as the characters in both the strings are the same. Like for example, in apple, we're just going to keep incrementing the counter until we reach a point where either the string has ended or the two characters don't match. So first we'll handle the case where the string has ended. So if I So here, since the first word has ended, we are going to return -1, else +1, else we are going to use this hash map to retrieve the order for the characters. So return hm dot. Yes, so going over the solution again, we are first creating a hash map and we are using it to store the order for all of the alphabets. After that, we just create a clone of the input array, we sort the new copy, and then we do a comparison to see if both the arrays are the same. So based on that, we know if the input array was already in a sorted order or not. And the logic is we have implemented using an alien comparator. So yeah, let's try running the solution. Oh, arrays also. And I can see a spelling mistake here too. Try it again. Alright, so 3 use cases are passed. Let's try submitting it. So yeah, the time complexity should be n of log n since we are doing a sort and we're using it to compare both the input string and the sorted string. The space complexity should be O of n since we are essentially just creating a copy of the input array. So I can see the memory. So this value is not correct. Like sometimes we submit, the value keeps changing. But yeah, that's the runtime and memory complexity of the solution.